Viewers, welcome to today's episode with Owen Engineering Services. Today we are going to talk about some certain faults that are unnoticeable by customers in a stabilizer. You may be using a stabilizer or you have a stabilizer in your home that is faulty but unknown or unnoticed to you because maybe it's still giving light, it's still powering on and then giving output. You may not know that the output is giving is not sufficient for your appliances and or it is damaging to your appliance. Now, whatever fault I show in any of this stabilizer is a fault that can happen to all brands of stabilizer. Any fault I show in any of this stabilizer is not particular to any brand. That fault can happen to any stabilizer and any capacity of stabilizer. The fault is not peculiar to 1000 watts, 2000, 15 or 5000, 10,000 watts. It can happen to any brand of stabilizer. Now, for the purpose of this video, we will do the illustration with 3 different voltage range because we don't have equal voltage distribution in all parts of our country. All right. Now, having said this, I want to say that this video is for educational purposes, for awareness, to create awareness, for illustration. Telling a customer, okay, if you have this type of challenge, assuming you packed out from the previous location, you were from unit A and you now relocated to unit B, you discover that your freezer or your refrigerator is no longer performing as it used to be, and you don't know that because the input voltage in your location has changed, and that because your stabilizer needs a few maintenance, that has affected the performance of your fridge. The output voltage of your stabilizer is not as it should be, and then you say that the problem is your fridge, and then you, worst of it all, you now contract somebody that is inexperienced, contracts the person that doesn't know how to truly evaluate and analyze faults, and they will now tell you, okay, this is the problem with your fridge, whereas there is no problem with your refrigerator, there is no problem with your air conditioner, there is no problem with your water dispenser, there is no problem with your deep freezer. Now, some people notice that the deep freezer in the kitchen or the fridge in the kitchen is working and that in the dining is not working, or in the room, and so on. Those differences. Now, sometimes these problems come from stabilizer. All right, let's go into the illustration. This video is not intended in any way to demarcate any brand, neither is it intended to promote any brand. It is just for educational purpose, just to show some common faults that may arise in stabilizers over time that are not known to customers. That is the purpose of this video. It is never to promote any brand of stabilizer or to demarcate any brand of stabilizer at all. Whatever problem here in brand A can happen to brand B, C, D till Z. So let's take note of that. All right, and that's a disclaimer. Let's proceed. For this stabilizer A, we have 3 power sources here. From this first source, this is my multimeter where we'll use to do the testing. For this particular power source, we have 104 volts as input source. For the second power source, we have 100 and let's check another point. We do not have inputs in that source. Let me get. For the second power source, we have 170 volts. For the third source, we have 214 volts. All right, let's proceed to see what voltage would each of these stabilizer give as output voltage. Let's say This is area 1 in C local government of maybe Akwa Ibom State or any state in Nigeria. This is area 2 in F local government of Akwa Ibom State or any other state in Nigeria, and this is area C. You have different voltage sources. Now you see the different performances these things will give. And then this fault can also happen even in the same location but different stabilizers. Okay, let's get straight to business. I now plug this in to the power source, the first stabilizer. Okay, so we have light there now. Having plugged that in, and we have output voltage, so I want to show the output voltage what we have. So from the input source that we have 104, it now gives an output of 207 volt. That's a good one from 104 volts. Now 104 volts is not really used in Nigeria except the light in your area is faulty, but it is performing well with 104 volts. So maybe that stabilizer is perfect for an American user. Abi. Okay, the second stabilizer with the same power source. Want to see what it can give? Is there light in the stabilizer? The case here now is that this particular branch cannot operate within a range of 104 volts. So it doesn't give output at all. Yeah, some brands are like that. While some are from the range of 100 volts, some are from 130 volts as minimum input. So when you go to buy, you check out all those features. They are written at the back of your stabilizer. Now, let me also show you an additional information. You see these products now. The manufacturer says that the output voltage will be 230 volts plus or minus 5%. 5%. While input voltage would be 230 volts plus or minus 56%. Okay, 230 volts minus 56%. So you calculate to 56% of 230 might be how much? You calculate that and find out. Plus 13 volts. 13 volts of each will give what value? That will make about 260. Minus 56, that will bring it down to about 100 volts. So make sure you always check that out so that you know the ability of your stabilizer. So as you can see, this particular stabilizer cannot give output within the range of 100-volt input source. Let's go to the next stabilizer. All right, so this 100-volt input source. Okay, so there is output, and we have a 217-volt output, 218. All right, we move to the next one. The last but not the least, this. With the 100-volt input source, we are able to have which is correct. This 189 volt output. Okay, so we can see that all of them except this one is able to use 100 volts. Okay, let's move to the input, the second input source. Remember, we had 100 volts, we had 100 and 100 watts. The second was 174 volts. That one is very frequent in some areas, most areas, not just some areas, in most areas of our state. That's the voltage we have from our electricity distribution companies. And then when we come to this stabilizer, it is giving us 263 volts. That's high. If you use it at your own risk. It should not be more than 260. That's the highest manufacturers will state in their products. I've not seen a product designed for Nigeria that they say it should exceed 260. Although it will work for some products, it will work, but it's a bit too high. It has exceeded 260, which is the highest threshold. Therefore, this stabilizer needs attention before it could be applied to any device within the Nigerian system. All right, so that is for that one. Now let's look at this particular stabilizer that did not give output when we used 100 volts. Will it now give output? Let's just be sure it's not in the delay setting. Okay, so it gives output now. Now what output does it give? 167. Now what did we even have from the input source? 170, and it is giving us what? 167. Okay, 170. That is garbage in, garbage out. It does not influence the voltage in any way. If you want it to delay, it can delay and give output, but it doesn't have any influence on the voltage. Now, how does a good stabilizer work? How is it supposed to be? It is supposed to raise the voltage when it is low, as well as bring it down when it is higher than the usual or the normal or the designed threshold. That is how a good stabilizer is supposed to work. So this one will now just save you, it will only save you as a delay timer, where it can only protect against power surge, but it doesn't have any influence on the voltage. That means this stabilizer is faulty. We are talking about some faults you, the customer, the user, might not know, but you feel and you think you are using a stabilizer, yet the stabilizer is doing you more harm than good. All right, let's proceed to the next stabilizer. Sorry that this particular stabilizer does not have a very good pin, but I will manage it for the purpose of this video. But let's proceed with the video. All right, so we have light there. Remember, we are using 170 volts as input, and then this is what we have as output, 246 volts. That's perfect for use within our Nigerian system. Let's try the last but not the least in this series. Okay, it's already on. So we have 285 volts. That's an over voltage. Can you see that? 285 volts. That's an over voltage. We have an input of 170 volts. Okay, let's go again. Remember, we had three input sources. Let's see what we have When the light is how many volts? This other power source now, the third socket. What do we have in that socket? We have 211 volts as input from that socket. This was 170, this was 104. All right, from 211, this stabilizer is able to give us 335 volts. Fluctuations in alternating current makes it 334 volts. Now, this can damage your TV, your phone chargers, your refrigerator, your air conditioner. Remember, I said this fault is not limited to size. It can happen in 10,000 watt stabilizer. It can happen in 5,000 watt stabilizer. It can happen in 1,000 watts, 500 watts. So it's not limited to size or any brand. That's an overvoltage. Remember, it performed excellently when we used 104 volts to test it. It gave us a very good output. But now that voltage is high, it is unable to stabilize and regulate the voltage. Remember, in our other video, our next previous video, we showed how a good stabilizer is supposed to work, how you should bring down the voltage when it is high and how you should take up the voltage when it is lower. All right, let's see what this other stabilizer does with 211 volts input source. Okay, so it takes it down to 207. So you will have these at home. You believe you are using a stabilizer. Probably you plugged it into your deep freezer, your fridge. Remember, this is not limited to 1,000 watts capacity. It can happen to 2,000 watts. It can happen to 3,000, 5,000, and so on. So you have this in your house. You plug it into your fridge, and then you feel you are using a stabilizer. It's not. It doesn't spark. It delays very well, and it gives output, but it doesn't have any influence over the output voltage. This stabilizer is faulty, but unknown to you, and this might lead you to losing a lot of money. You contact a technician that does not know how to analyze faults. He will come and tell you your freezer, your refrigerator, your air conditioner, water dispenser is faulty, whereas it is not. It's a stabilizer that is making it unable to start. Okay, we proceed. The next stabilizer. All right. So, output of 306 volts. You can see that. Even the meter is saying that is too much for a stabilizer. Okay, let's see. The last but not the least, 300 and something volts can damage your TV, can damage your compressor, be it AC or refrigerator. So this gives 256 volts. That is within range. It is able to regulate. That is within range. This is useful. So, but then remember, this gave over voltage and this gave over voltage. None of these stabilizers that is not working, like there is none that is not giving output. There is none that is even vibrating for you to know. So the essence of this video was to inform you, to educate you that there are some faults you do not know. So when you notice this drift, do contact ON Engineering Services for proper evaluation and solution recommendation. Thanks for watching. You have a lovely day ahead.